Hello everyone and welcome to your Chapter 8 study guide. The first set of directions say to write the ratio of the first measurement to the second measurement. Use common units and simplest form. So the first measurement they give us is the height of a tree. They say is 14 feet. The second measurement is the width of the tree. And so what we're going to do is we're going to do 14 feet over 4 feet. And then we are going to reduce this fraction. You can either do that in your head or using a calculator. I think it's smart to trust but verify. And so when you type that into your calculator, if it gives you a mixed number when you use that fraction button, you can just click second and hit that fraction button one more time, and it will give you the improper fraction, which is 7/2. So that simplifies to 7 feet to 2 feet. You can write it as a fraction, or you can do it as with the colon in between, okay? Either way is totally fine. So 7 feet to 2 feet. Or you can write it as the fraction as 7 feet over 2 feet. That is the height over the width of the tree. All right, now we have the first measurement to the second measurement, length of the iPhone over the width of the iPhone. And so we have an iPhone that has 5 inches over 3 inches. You could type that into your calculator, but that does not reduce at all. That is already in simplest forms. That is going to be, you could do 5 over 3, 5 inches to 3 inches as a fraction. Or if you wanted to do it with the colon, 5 inches to 3 inches. Okay, so that one could not be simplified. All right, now we've got the width of a football field, comparing that to the length of a football field. It's obviously longer. If you've been to a football game, you know that. That's going to be 50 yards, already in the same units, no conversions needed, over 100 yards. Many of us will be able to do that in our heads. We know that's going to be a 1-to-2 ratio. 1 yard for every 2 yards of length. 1 yard of width for every 2 yards of length. If you wrote that with the colon, it would be 1-to-2. Okay, or as a fraction. All right, now we want to write the correct ratio. We're going to have to pay attention to how they word it this time. We have the height of a tree. The height of a tree is 38 feet tall. So height is 38 feet tall. The shadow is 4.5 feet. So write a ratio from the shadow to the tree height. Okay, so we want to go shadow to tree height. We want to go pink to blue. So what is our pink amount? Our pink amount is 4.5 feet. That shadow, since we're starting with that, is 4.5. So it's going to be 4.5 feet over the height of the tree, which is 38 feet tall. Now, you could leave it like this as a decimal. Oftentimes on standardized tests, they're going to have you convert that to a fraction because oftentimes they will use whole numbers in their fractions. So you're going to type into your calculator because it's a decimal, you have to use the division symbol. Think decimal division. So it's not going to work. It's going to give you an error message if you try to use the fraction symbol. So you're going to type in 4.5 divided by 38. And then we're going to go convert that to a fraction. So click second and then hit that fraction button. If you have a different calculator, just come ask and we can help you with that. That is going to simplify to 9 feet over 76 feet. So that's if you wanted to convert it to whole numbers. Another way you can write that is 9 feet per every 76 feet. Shadow to tree height. Okay, so you can use the colon or the fraction, do it as a fraction, or you can use the colon. All right, now we have the base of a triangle is 6 inches. The height is 2. They want us to write a ratio from the base to the height. So that is going to be blue to pink. So what was my blue? My blue was the base of the triangle is 6 inches. So it's going to be 6 inches. I'm going to do that in blue so it matches. 6 inches to 2 inches. We know that that is going to simplify to 3. If you wanted to still write that as a ratio, we're going to say 3 over 1. 3 over 1. Another way you could do that is to write 3 inches colon 1 inch. Let's say 4. Okay. All right, now let's do the next section. The next section is my personal favorite. When they give you extended ratios and they ask you to find for the original pieces. So they're going to give you the extended ratio that has been fully reduced. So it says the perimeter of a quadrilateral. Think quadrilateral. Remember that we know a quadrilateral has 4 sides. So this extended ratio is going to be 1 to 3 to 4 to 6. It says the perimeter is 112 inches. Perimeter is 112. So all the way around the quadrilateral is 112. I like to draw a picture. We don't know what this quadrilateral looks like, but I'm just going to sketch one that has 4 sides. So it's not that each side is 1, 3, 4, and 6. It's that they have been reduced to 1, 3, 4, and 6. I'm going to put an X next to each of these things. The original is going to be multiplied by what we find that it has been reduced by. So it says the side lengths are in the ratio of 1 to 3 to 4 to 6. What are the measurements of each side? So here's what we know. We know that it is going to be 1x plus 3x plus 4x plus 6x, all the way around the outside of that shape. Oh, goodness, plus 6x. All 4 of those pieces in this quadrilateral should have a sum of 112 originally. They have just reduced this out. So then we're going to combine our like terms. We're going to do 1 plus 3 plus 4 plus 6, and we get 14x equals 112. And so what we're doing now is we're finding what did they simplify this by. So we divide by 14 on both sides. I get 112 divided by 14, and that gives me 8. So if I want to know what the original pieces are, I'm going to go back and plug them in. 1 times 8 to 3 times 8 to 4 times 8 to 6 times 8. And we're going to go back and plug in what they have reduced. They divided by 8 on each of those. So what are the original pieces? 8 to 24 to 8. We're going to do 3 times 8, and then we're going to do 4 times 8. I think it just asked you for the largest. I'm going to go ahead and find them all. 6 times 8 is 48. So that's what all of the pieces are, what are the measures of each side. Oh, no, it doesn't. It asked me for the pieces of each side. Just to make sure you did it right, go back and add all those up. 8 plus 24 plus 32 plus 48, and it does add up to 112. So those were the original pieces. That is what that would simplify to. So these are my original pieces before they simplified it. All right, a band director, Mr. Horton, needs to order uniforms for his students. The size for small to medium to large, so they tell you what order it's in, small to medium to large, is 3 to 8 to 4. There are 195 uniforms total that he has ordered. So how many mediums does the director need to order? So again, we know that I'm not only ordering 3 smalls, 8 mediums, and 4 larges. This has been reduced. So this was 3x, 8x, and 4x. That total, it says, should add up to 195. So when I add all the smalls, mediums, and larges together, that means that I should have a sum of 195. So 3x plus 8x plus 4x has a sum of 15x. We're going to divide by 15 on both sides. So 195 divided by 15, and that is going to give me 13. That is the value of x. What we want to do is find what were the original pieces. So that's going to be 3 times 13 to 8 times 13 to 4 times 13. And let's see how many mediums he ended up ordering. So you're really just having to do it 8 times 13. The answer to that is 104. That's the total answer. You'd say 104 mediums. But I like to find the number of smalls and the number of larges as well, just to make sure I did this problem right. I ordered 39 smalls, and I ordered 4 times 13 larges, which is 52. When I add up all those pieces, so 104 is the amount of mediums. 104, I'll write mediums below it. That's my final answer. But I did have 39 smalls, and then 52 smalls and 52 larges. So I know that I did that right because I do have a sum of 195. All right, the measure of supplementary angles. What does supplementary angles mean? It's a pair of angles that have a sum of 180 degrees. So it says they're in the ratio of 1 to 4. Those two angles are in the ratio of 1 to 4, which means that this is 1x, this is 4x. This has been reduced. So we're trying to find the original pieces. What do we know about supplementary angles? We know that they have a sum of 180 degrees. And so I know that 1x, let's do that in color, plus 4x has a sum of 180. When I do those, x plus 4x, that gives me 5x equals 180. So one angle is 4 times the size of the other is what this is saying. So I'm going to divide by 5 on both sides, and I'm going to get x is 36. So if I want to know what are my OG pieces, I'm just going to go back and plug it in. I'm going to go 1 times 36 to 4 times 36. They want to know what is the value of the smaller angle. So really all you're having to do is 1 times 36. I go ahead and find both. So one angle is going to be 36 degrees. The other angle is going to be 4 times 36, which is 144. So the answer to my question is the smaller angle is only going to be 36 degrees. Okay. All right, number 9, and then I'll make a new video for the next section. You make a scale drawing of a tree using the scale. 5 inches equals 27 feet. You're going to want to make sure you include units so that you can stay organized. 5 inches represents 27 feet. It says if the tree is actually 67 feet tall, so that goes across from feet, 67.5 feet tall in the denominator. How tall is the scale drawing? So we want to know what is the scale. So I'm going to put an X here, and then we are just going to cross multiply. So that is going to be where 27x is equal to 67.5 times 5. 67.5 times 5 gives me 337.5, and then I'm going to divide by 27 on both sides. When I do that, I get how tall the scale is. So I divide by 27, and that gives me 12.5. Now make sure you include your units. That's going to be 12.5 inches. 12.5 inches represents 67.5 feet. So the scale drawing is going to only be 12.5 inches tall. Lance the alien is 5 feet tall with an 8-foot shadow. Then it says, okay, so let's write that down. Lance is 5 feet tall. I go ahead and write that. 5 feet, I'm going to write tall with an 8-foot shadow. 8-foot shadow. We know that it says if the tree's shadow is 32 feet long, so the shadow, 32-foot shadow, what is the actual height of the tree? So it's asking how tall is the tree. Okay, so I'm going to cross multiply these. And when I do that, I'm going to get 5 times 32 as one cross product. That's 160. I'm going to set that equal to 8x, and then I'm going to divide by 8 on both sides. 160 divided by 8, of course, gives me 20. So x is going to be equal to 20. What does that represent? That is how tall the tree is. The tree is going to be 20 feet tall. The height of the tree is going to be 20 feet tall if it casts a 32-foot shadow.